All right, so just before I start talking about any technical stuff, in case you're not familiar with Tumblestone, I'm going to play a quick video. Tumblestone is essentially a match 3 puzzle game in the style of a block smasher column Tetris-y kind of. It's hard to explain without playing it, but it's that. It's what you just saw, and it's been created by myself in addition to Alex and Justin here, and also Mario Castaneda, who did the art for the bridge. It was, of course, made in Unity. That's why I'm here talking to you guys. It's implemented as both a single-player and multiplayer game with both local play and online play via networking. Because it is Unity and because we started this before the 2D toolkit became available, it's technically a 3D game, although it's completely implemented in 2D using all 2D sprites, PNG images, and whatnot. Oh, and also we're ambitiously coming to every single platform that Unity supports. Consoles, modern and old, Steam for PC, Mac, Linux, and tablets and phones. So basically anything Unity currently, or probably even in the future, will support, Tumblestone will be on. And so before I tell you about Tumblestone's actual architecture, I'm mostly going to give this talk as an overview of the architecture in terms of MVVM, Model-View-ViewModel. So confusingly, when I say view model really quickly, I'm talking about a component called the view model. I hate the way it's named, but I didn't name it. So essentially, it's creating your programming structure into essentially 3 layers. The bottom layer is the model layer. This is where all of your primary game logic will live, and any kind of game. I'm going to say game objects, meaning like objects related to your game, but if I say that really quickly, I'm talking about a Unity game object. Terminology is not really my friend in this slideshow. That's where your game model objects, your game logic live. At the top, you have your viewing layer, which is where all of your essentially rendering happens, where all of your objects that are going to be rendered happen. In some game programming paradigms, this is kind of mixed together. XNA, for example, you'll have an object with an update and draw function, and that kind of does all the rendering and game logic in one class. What we do with the separating the models and views, whether it's MVVM or MVC or anything like that, it takes the view layer and the model layer into 2 separate layers that are completely independent of each other. The view model layer is something that binds them together. It basically handles any kind of presentation logic. So, for example, if you have an object in your game world and it's 3D space, and you need to translate it, say you have a screen scales up and you need to translate the coordinates or whatever, it'll handle that kind of presentation logic, but it doesn't handle any game logic. So I guess to recap what the layers do, the objects in the model layer, the model objects, represent in-game things. This might be your characters, your enemies, your bullets, whatever. But this is the actual objects, C# objects that make up those models. View objects are corresponding objects, which Unity will eventually draw. And I'll be going into a lot of this more later with actual implementation, if this isn't like sinking in, if you're not familiar with MVVM, so don't be too worried about that. But in the context of Unity, this is what actually a game object or prefab is. So you create a game object in your Unity scene, and this is, in this context, what we're going to call a view. A model view is something that pairs the view to the model. And Unity has no context of the model. This is our construct. It's just an object that we're creating outside of Unity. But a view model object will pair that to the Unity game object. So this is a script. A model behavior, which you're all very familiar with, I assume, you attach to a game object or a prefab in Unity. In this context, that's what a model view is going, or a view model is going to be. some additional notes. The view model ideally should be as simple as possible. While it does handle presentation logic, any actual game logic, like I make an input, this character moves, that's going to happen in your model layer. That's going to be something that happens on your model objects. The view model, think of it as like a binding between the models and the views. So it should be as simple as possible. Each view model has one model object that it references, exactly one. And similarly, each view object has exactly one view model object that it references. While you can't have multiple in the opposite direction, for example, one model object may be referenced by multiple view model objects, it's ideally should be as close to one-to-one because in my opinion, as close to one-to-one means clean code. If you have up the chain, one view has one view model, has one model, and vice versa, it's very parallelized, well-structured code, although it doesn't need to be one-to-one-to-one. And as I've been saying, the view model essentially reads information directly from the models, and they writes to the views and changes components in both. But that's how kind of the views and the model will talk to each other is through this view model object. And because of the references that a view model holds to a model doesn't hold a reference to the view model. The model doesn't know about the view model, and it doesn't care. So for example, in your game logic DLL, you might have a bullet firing across this scene. It doesn't know that it's being watched. It doesn't know that it's being drawn. It's just kind of existing in its abstract game logic. It doesn't necessarily need to know that a view model or view models are watching it. So I'll give you a brief rundown about how the Tumblestone architecture is structured. We have this overall solution, Tumblestone.sln, contains several projects. Tumblestone.common and Tumblestone.unity are what I'm going to be talking about the most. Tumblestone.common is our core DLL. It contains all of our game logic, and that's where all of the model objects live. Tumblestone.unity is essentially the same project file that Unity would generate for you. So for example, if you created a new Unity scene, it's going to generate a project file for you that contains all of your scripts and your model behaviors. That's what this is. The modeling behaviors are the view models. That's what Tumblestone.unity contains. And we have various other DLLs. I'm not going to go into too much because they're not really related to the MVVM stuff. But we have a test DLL, which houses all of our unit tests. We have like 500 plus unit tests because it's a hobby of Alex's. And that references Tumblestone.common. And then we have our puzzle generator and platform-specific stuff. And I'll probably give talks about those months and months from now. But anyway, Tumblestone.unity has a reference to both the common DLL, which is kind of our core DLL, and the Unity engine DLL. Just like if you were to create a new scene in Unity, it would automatically make a project file for you. It would automatically have this reference. So this has all of the Unity goodness, like the vector math and all those other classes that you might like. So another way I'm going to talk to you about the architecture of Tumblestone specifically is giving you a rundown of one frame. So this is the pattern that happens as one update loop takes place. So first of all, we have a root game object in our Unity scene, and that will have update automatically called. Unity just does that for us. Now when that happens, we manually plumb over some properties from Unity that we couldn't get because of our lack of a Unity reference. So for example, some input, the current game clock, anything else gets plumbed over into our root model object in our common DLL, which houses all of our models. And then the update function on our root model gets called, which hierarchically in a giant tree through all of the models calls update on every single active model. Now this will add model objects, remove model objects. So for example, if this is a frame where like someone is firing a gun and a bullet comes out, it's going to say, oh, on this frame I need to create a new bullet. It's going to create a new model object. In addition to updating the positions of everything, execute any other miscellaneous game logic you may have. Now all of this is happening inside of this one update call. This is that one line of code that gets called from Unity. It goes through our entire game tree. Every single model gets updated in this one giant call stack. Then immediately after this update gets called, Unity is going to automatically call update on all of the other game objects in the scene. So what this means is this is where all of the view model code gets executed. So in one frame, in one big pass, all of the model code gets executed in one giant tree, and then all of the view model code gets executed. And that's not necessarily a tree, that's just however Unity decides to do it, but it doesn't matter at this point because all of our model code has been executed, and all this is doing is copying values over from the model and setting them to the views. So when all of this is done happening, it sets transforms. If models were added or removed from our Tumblestone.common layer, it will correspondingly add or remove views from the Unity scene. And then after that, Unity does its magic and automatically renders things to the screen. Now, like the next 5 or so slides are just code. So this is kind of the implementation of how we implemented MVVM with Unity. Before the talk, a lot of people were asking me, like, I'm really excited to see how Unity implements MVVM. Well, they don't. This is something that we've done because we like the separation of the model and the view layer. So this explains how to do it essentially. And afterwards, I'll post these slides. So if you want to cut any of these code snippets out to make your own MVVM system, you can do that basically from here. So to start, we're in our Tumblestone.common DLL. This is our model object DLL with all the models. And what a model is, it's essentially all of the models are interfaces. And I have this base interface called iSpatial. This represents something, a spatial object. It has an XYZ position, it has an XYZ rotation. We give it an opacity because in Tumblestone things fade in and out all the time, so just everything has an opacity. You're welcome, obviously, if you implement this to give us anything else, you might want an XYZ scale, you might want a full color spectrum, whatever. It doesn't, anything that is shared by literally everything in your game. And of course, the update function. The root model, which everything implements iSpatial, has an update, and through the entire hierarchy calls update. Here's just an example of how iSpatial is implemented. Tumblestone, as you just saw from the video, has blocks. It's a block smashing game. So I'm going to kind of give examples in the context of blocks and boards. A board contains essentially a big list of blocks, and the blocks is something that you can shoot and make it dead. It's got various properties, block type, block state, et cetera, et cetera. These are very game specific, so I'm not going to go into it in more and more things, and it implements the iSpatial properties. One thing to notice is that these interfaces are public. They're public because the Tumblestone.Unity DLO needs to reference them. And also we have a test DLO referencing them, and if you ever write any other projects, you can share this one as a reference, and because these are public interfaces, you can reference against them. Notice, however, that the actual implementation of a model is internal. That's because the view model doesn't need to see any of this. It doesn't need the inner workings of the actual block. It doesn't need to know the game logic. All the game logic is contained in the Tumblestone.common DLL. We only expose the things that we essentially might need to use to draw things. So now stepping over to the view model layer, which is where a majority of the code I'm going to talk about lives. This all the Tumblestone.Unity DLL contains all the view models, objects. Here's just like iSpatial was the base interface for all of the model objects. We have spatial view model as the base class for all the view model objects. This implements a model behavior, meaning that it's a Unity script. You attach anything that implements spatial view model to a game object as a script, and automatically it gets nice things like update from Unity, et cetera, et cetera. Any Unity defined function you'll get for free. And this is a generic type T, where T is the type of model. So iSpatial being a model object, T if it's also a model object, meaning it is either iSpatial or implements iSpatial, you pass that in this generic override. And so we use that type of a model to actually store a model object. We call that the data context. So this is where the view model has a reference to the model. This is the view model, and it has a reference, T of the type model, to the data context. So anytime you're in any of these spatial view models or any class that implements it, you'll have a reference to the data context object, which is just the model. Maybe I should have called that model to be more clear, but whatever. It has an initialize function, which you pass in the actual model and it sets it. We'll come back to that like 4 slides from now. It'll be relevant. But for now, let's take a look at the update method. This is a Unity function, since this is a model behavior, meaning it's going to get called every update cycle. And this essentially sets all of the transform properties. This is what I was saying, where the view model is essentially something that copies values over from the model to the view. This is where this happens. Basically, any of the times I change the XYZ position or rotation in the model in my game world, this is where it gets mapped over onto the views in Unity. One thing to note, though, if you're familiar with performance and optimization in Unity, don't ever just set the transform value every single time. Unity is terribly, terribly inefficient when it comes to just like setting a local position or anything on a transform, because even if it's the same, it will go through this giant glob of who knows what underneath the engine and take up a lot of time. So what you should really do, I didn't show it here because there wasn't enough room on one slide, but you should store the previous value of XYZ position, whatever, and only set the transform if it's changed. So just cache these values. If it's different, then update the transform, otherwise leave it alone. But anyway, that aside, I'll show an implementation of the spatial view model with my example of the block view model. Because on the other slide we saw that spatial view model was a generic of type T, where T is a type of model. Block view model extends iBlock, which I showed you a few slides ago. On the default Unity function start, we set a game object that we have a reference to called glow. If you noticed in the video, if you notice playing Tumblestone, as you move your character around, you basically highlight a block. You have a little pointer and you're highlighting a block has a little glow around it. It's kind of like a reticle to show you what the active block you're about to shoot is going to be. So this is just an example of how we turn that on and off based on whether or not you're pointing at the block. So on update, let's ignore this section for now and come down here. The data context, I didn't show you any of the block implementation, the game logic, because it doesn't really matter, it's all game specific. But it sets is in line of fire on whether or not the user is pointing at a block. When that's true, I want it to glow. When it's false, I don't want it to glow. So basically, on every single update, I check, is that property on the data context different than the one I have? If it is, I update my cache of is in line of fire, and I set the glow object to active or not, whether or not I'm pointing at that block. So you can see from this line, glow in the prefab for block is just some child called glow. It's got a sprite renderer. The sprite renderer has a texture for the glow block. You're all pretty familiar with that if you've used Unity. Coming back to this line, this is how a view model determines whether or not a view should be removed. So the view model handles whether or not views are added or removed based on the state of the corresponding models that they have a reference to. So I have is alive, which is a property of iBlock. Again, I'm not showing you the implementation of this in our specific game logic because it's not important here. But anyway, like if you shoot a block, it goes pew, flies off the board. You don't need to be drawing it anymore. You don't have to have a reference to it. It's gone. It's dead. So at that point, the actual game logic code in tumblestone.common.dll will set is alive to false. When that happens, the corresponding view model, block view model, says game object to destroy this. Done. And it returns because you don't want to do any additional updating the block's dead. Just return and be done with it. So at this point, game object.destroy will remove that game object from your Unity scene. Now let's go one level up to show how views are added from the view model layer. So here's a board view model, which is the view model implementation of the iBoard model. I didn't show you iBoard because it's not super important, but what is important is the way that it adds blocks underneath it. So we have a prefab for our board in Unity, and that prefab has this script because every prefab view has a view model script. That's how the view gets a reference to view model. And in this script, we have this public game object block prefab. So in our Unity editor, we can go to the prefab, pull up the script, and it'll have a little UI to add another prefab for the block prefab. So we take the block prefab that we used on the previous slide, just drag and drop it here. And that's how you set that public property for block prefab. And that's what all blocks that are created are going to be created from. So in other words, a parent which is going to create children needs reference to all those child prefabs in that prefab. So I'm not showing any implementation for iBoard, but it has this function called get new blocks added. The game logic code, every frame, will know what new blocks are added to the top of the board, and it will keep those available in this function return for the rest of that frame. So this gets cleared out at the beginning of every frame. If a block was added to the board, it's available in this function return for one frame, and then so on every frame. You can do this with any object that's created in your code. So whether your guy's firing bullets or spawning enemies, you're going to want some hook from your model layer to be able to return what anything was created. So if you're firing bullets, what bullets were created this past frame, what anything was created this past frame. So this gets the new blocks that were added. So given this list of blocks to add, I simply cycle through every block model and create it with this view factory, which I'll show you on the next slide. This passes in two generic types, the type iBlockModel and the block ViewModel that you saw in the previous two slides, in addition to the actual object itself. So the block is the model object, it's a reference. The block prefab, which I just described, and just itself, just so I know the parent in the next function. So here's that function. Create. It's generic of two types, the type of model and the type of view model. So in the previous slide we saw this was essentially with iBlock and block view model. And the parameters that I described in the last slide. So it starts off by creating the game object using gameObject.instantiate. And it does that based on the prefab that you set in your Unity editor. Next, it simply sets the parent, because when you're creating a child, I need to know who the parent is. But this line here is probably the most important line of code I'm going to show you. This essentially links up the view model, and the model all together in one line. So in Unity, every view has a script attached to it by this pattern, where that script is the view model. Getting a component of that type from that script, essentially from that view, gets the view model, and it calls that initialize function that I showed you on that slide, that spatial view model slide, and passes in the actual object where it gets set. So this sets the data context, the model being the data context, on the view model for the view. So it links everything together. And based on this line of code, everything else that I've showed you so far will just work. So that's all the code I'm going to show you, and essentially that's all you need to start implementing your own MVVM system in Unity. It's pretty straightforward. I've only showed you one implementation, so of course you'll have to implement every type of object that you use, but this is the base implementation that everything should derive from. Now, almost for simplicity, I just used gameObject.destroy and gameObject.instantiate, which I hope made a few of you cringe. The reason is, in reality, you would really pull stuff. GameObject.destroy and GameObject.instantiate are fine when used in moderation, but they're actually really, really bad in terms of performance if you want to, use them regularly. So, like, if you have a game like Tumblestone, which is constantly adding bullets and particles and blocks, or especially if you have like a bullet hell kind of game, you absolutely don't want to be using this every frame. So instead, what you should do is, in your own view factory or whatever you call it, make a array or list of a large enough size to hold every kind of game object type that you're going to need. So for example, if you're making a shooter game and you think, I'm never going to have more than 500 bullets in my scene, ever, and you're sure about it, then you can create an array of size 500 of game object types of your bullet that you can store, and anytime it's set to inactive, you can go and look for a bullet that's inactive, and you can set it to active and put it where you want it, rather than calling gameObject.instantiate. So essentially, calling gameObject.instantiate will allocate memory, it'll pull textures around and put them in the right places. It's just really expensive. Doing this is just going to put something from somewhere and call it turn active. All your textures are going to be set, all of your memory is going to be created already, so you're not going to be allocating new memory. It's basic pooling. Similarly, for destroying, you don't call gameObject.destroy this. You put it in the middle of nowhere off camera, set it to inactive, and forget about it. It's still in this array, so you can come back on the previous step if you ever need it again and just repeat forever. One thing to mention, instead of just doing that, you also want to implement something that I call soft destroy. This is going to set any object references to null, for one. And why you do that is so the garbage collector doesn't get too confused. So for example, if you have this game object with a script, and it references a bunch of objects in your model layer, or even your view model layer, because those are objects, that means it has a reference to them. That means the garbage collector isn't going to collect those if nothing else is referencing it. By the time you're soft destroying, theoretically nothing else will be referencing it, because why else would you be soft destroying? So if you just set those values to null, the garbage collector can kick in and get rid of those objects. And similarly, you should do this recursively on all your children. So if you have this big hierarchy, A references B, references C, etc., you should do that bottom up so that everything gets set to null and all your children get garbage collected away every layer. That's kind of just like basic view pooling in Unity. So why might you want to do all of this? Seems like a lot of extra work. For one, if you do this, you can have a DLL with all of your game logic and all of your model objects that are completely independent of everything else. Now, this isn't a strict requirement of MVVM. If you really needed your .common DLL to reference Unity engine, you can. That's okay, but you don't need to. And that's pretty important because you can make a straightforward conversion to other game engines if you want to do that. But Unity supports everything. Why would I want to do that? You have Unity to XNA. Are you insane? Yeah, well, no, because the license fee to port to Xbox 360 for XBLA is $25,000, and I don't really want to pay that, so we're going to port to Unity, or port to XNA, sorry, from Unity. It seems a bit backwards, but we're doing that for Xbox 360 only because we don't want to pay a $25,000 license fee. So having a .common DLL with all of your game logic that doesn't have any Unity dependencies is really nice for that, because all we have to do is implement the views and view models, whereas 90% of our code and all of our game logic is in .common. You can create build servers. Build servers have a hard time with Unity. However, they are usually, if you use like Azure or any of the Microsoft BizSpark stuff, very well integrated with the regular old C# and Visual Studio stuff. So we can have build servers, which we kick off every night. They go through all of our different environments. So if we have expo builds or debug builds or whatever, they run all of our unit tests and they give us messages in our team chat when something's broken. It's beautiful. So you can have this by having no Unity references. And unit tests. Unit testing any of the view model layer stuff in Unity is basically not, I don't know if I want to say impossible. It's not easy. We didn't even really try that hard. So we didn't want to do it. Visual Studio has a really nice unit test integration, and if we don't have this Unity reference, we can do that. So by having a common DLL with no references to Unity, we get a lot of advantages. And we are able to do this independence because of the separation of the views and the models. So whether this is applicable to MVVM or MVC or whatever model view separation paradigm you want to use, they're all very similar anyway. This is an advantage. And similarly, models are completely independent of views, which is huge. If you for example, we recently completely overhauled our lobby system in Tumblestone. So Alex was like changing it from like displaying text onto boards to like making no boards at all and displaying in a really nice modern UI with fancy avatars and stuff. That didn't change any of the model code. None of the game logic was changed at all because there was no coupling there. It was completely independent. So this really increases productivity because he didn't introduce any bugs in the model code. At the same time, I think Justin was able to change the model code as he was doing networking stuff without changing the view code at all. So at the same time, over the course of weeks, these two guys could like edit these two lobby components without actually touching each other's code nearly at all because they're so independent. So a huge boost in productivity there by separating these two, and a huge way to reduce bugs and just general like messiness. I feel like it's kind of messy when the views and models are together, which brings me to my next slide. I feel like this is really a clean, kind of a tree hierarchy-based approach. So if you can see this really low white on light blue picture, I feel like the MVVM approach that I just described, because it has this root model object, which not recursively, but which hierarchically calls in through all of its children, which call their children, in one nice big update loop. You don't have what Unity kind of wants you to do by having every script know about every other script and just have this giant spaghetti code, which is kind of the Unity behavioral pattern, which I absolutely hate. It's messy and complex. So having this really straightforward, if you go back to the slide where I showed you each the one frame as it calls through the Tumblestone.common layer, it's very like this nice clean tree over here. To be fair, I'm listing some disadvantages. It is slightly more complicated. You do have to implement this entire other layer, which links up the models and the views. So anytime you change a property or add a new property or remove a property on a model or a view or vice versa, you've got to also do it on this model view layer. So if I add a glow to a block now, and I want every time it's high, someone's pointing at the glow to appear, I have to also implement that in view model. It's not an enormous overhead. You actually kind of just get used to it, like doing it twice, but it is an overhead that you have to keep up with. And in terms of time and memory in your system, it is slightly less efficient. You are copying values over. You're not setting values directly. So especially if you're caching transforms, which you absolutely should, you're storing everything twice. So for every model object, you have a view model object. And so you have an extra object allocated. You have all of the properties of that object also allocated. So if your model has 20 floats, you might have 20 floats on this view, which seems like a little, but it can add up slightly. Now, with that said, in terms of memory, it's not that much overhead, because if you think about all the memory that you're allocating in your objects compared to all the memory that you're allocating with your textures and your audio and stuff, most likely, unless you have like millions of little particles or bullets going around that you need models for, you're not really going to see that much of an efficiency loss, in my opinion. So that sums up how we implemented MVVM in Unity. Question?
Yeah, I saw that you had a lot of polling in your model, and I was just curious if there was any pitfalls to using events.
You can use events. A lot of MVVM implementations, like SilverLayer or whatever, do go event-driven. I kind of have a bad experience with events because they do allocate memory kind of secretly, especially as you create them. Like, stay away from lambdas in games. Don't even attempt it, because it will secretly allocate a lot of object memory, which kicks in garbage collecting, especially on 360 or PS3. So that's primarily why we don't use events, as opposed to doing it a kind of a dirty approach in our view model. So we try to limit events for performance reasons.
Did you implement your own physics system, or is there a way to use the Unity physics system in this?
That's a good question. That's a good question. We do not have a physics system in Tumblestone. It doesn't really need one, but using this system, it would be pretty difficult to go against Unity's physics, because physics is game logic. But now that you bring that up, I forgot a point that I wanted to make earlier in the advantages section, is that if you do implement your own physics engine and don't use Unity, so say you're using Farsi or something that is all in your model in game logic DLL, by having a separated model layer and view model layer, you can have no trouble running that as a separate thread. So any of your models can be spun off in threads, and because they're independent of the views and the view model just copies data over, it should all be pretty thread safe. I mean, you may want to double check that, but it should all be very thread safe by default. So if you happen to have your own physics engine, that there's a huge advantage to just turning on threading to that.
So just sort of as a philosophical question, if I've got a block that's getting deleted, mm-hmm. and I have sparks and effects that are mm-hmm. happening, is that eventually that sparking view needs to get deleted. Do you think of that as the responsibility of the game logic of the model to read this thing, or do you think of that as a view?
I think of that as both. I think it's both. Because essentially the view code and the model code should be kind of aligned. So if you're going to have a block that goes away, it's going to go away both in your model layer and in your view layer. Now you brought up like sparks and effects. One of the things you can do is be a little bit messy with the one-to-one relationship and not have all the particles and effects in your model layer. You might have like a particle emitter in your model layer, which simply says, I'm making this many particles of this type at this point, and have all of the implementation in your view layer if you want to do that. Of course, that makes any kind of multi-platform stuff that much harder, because you'd have to re-implement the extra logic. But you could, I mean, it's just semantics as to what is game logic and presentation logic. So if you say, I want to use a Unity particle emitter, you'd have the model layer tell you like what, where, and when, and just have the Unity layer actually do the implementation.
You mentioned also that your game objects have a script that is the view model.
Right.
And other things you said, it seemed that you're implying that you tend to have like few scripts per game object, maybe rather than the way Unity likes to kind of do it, which is like a million little scripts that do one thing.
Yes, with this approach, ideally you have one script per game object, and that one script is your view model. Yeah, there are, I think maybe there are a couple places we got lazy with it and have extra helper scripts, but in the cleanest, purest sense of this pattern, you would have one script per game object, and that's that game object being your view and your script being your view model.
Yeah, I've plopped both of those ways, and I found that I always tend to go with that one script or view per
Yeah.
object, but then when I'm just prototyping or something, I can play around.
That's why we got a little messy at times.
Yeah.
A lot of times we just start like prototyping new features and kind of sticks around. Yeah, go ahead.
Have you guys used anything like, have you considered Strange IOC or U-Frame for your purposes?
No, we've kind of just wrote it our own.
Okay, I was just curious if you have, then maybe give us your thoughts, but it sounds like you have.
No, we haven't. Sorry.
It's kind of in the weeds, so feel free to say you don't want to answer right now. I'm curious if you're into a bootstrapping problem by having your game logic in a separate DLL, because Unity needs a reference to that DLL before it can load any of the scripts.
Not really. We found like loading the DLL is
Do you have any custom editor tools, like editor extensions that reference classes from the Tumblestone common DLL?
we have plenty of custom editor tools. I don't think we actually reference that.
Oh.
And that's referenced by plenty of stuff. So like we've got like some console programs that we also run, like just like quick automatic run throughs, just as an additional unit test without actually being a unit test. I wouldn't call that a unit test, but you know what I mean. In the unit test, of course, run against them, but we don't use it there.
We don't extend the editor at all with like custom style data or anything like that.
Right.
If we did, that would be just directed entirely against the view layer. So it'd be a separate code that
On your workflow, like when you need to make a new model, a model view, or a view model, you start by creating a model in your common assembly and then compiling that and then going and making the view model? Like what's the workflow like?
The workflow really is kind of everything all at once. Yeah, if you were just making something completely new, like suppose we were working on this and we didn't have a block yet, for whatever reason, just as an example, we would make the game object of a block in our Unity scene, right? And that would be a prefab. Then we would, at the same time, like in the same flow, make the model block and the eye block that the game object, that the game view, the view model would reference. The view model would create the view model too. So we'd create all of those in the kind of one flow. So, but more often what happens is we shouldn't do it like this. So I'm not advocating it, but in practice what happens is we kind of create models which we use in other view models, and then, okay, that works, and then we eventually make a new view model, or we get lazy and one view model becomes enormous when it shouldn't. But if you just want to get something up and running real quick, you don't have to do the full flow, but you should.
Is there any platforms that gave you issues? I mean, other than Xamarin?
We're not using any platforms other than Unity.
I mean, like
Xamarin.
the platforms you should do.
Oh, yeah. They all give you issues for plenty of reasons. It's enough for another talk. Yeah, seriously, like I spent like a week once just debugging a black screen with no error messages on the Xbox One or any forum post related to it. It turns out I had a method longer than 124 lines of code. Who knew? Don't do that. One day I'll give like a 5-hour talk about that kind of thing.
What code editor do you use?
Visual Studio.
Does that work on Mac?
I don't know.
Only if you run parallels or
Yeah,
whatever.
you know,
I don't use a Mac.
Yeah. All right.
So you mentioned you have your build servers send messages to your team chat. Curious what you use for your team chat.
We use HitChat by Atlassian. Yeah.
It's free.
Yeah, ask Alex afterwards. He knows all about this kind of stuff.
So it seems like a pattern where the views are generally being created in response to changes to the model.
Right, everything's kind
So-
of model driven.
I'm curious how you handle level editing. When I'm starting by building a bunch of objects in a Unity scene,
Mhm.
is there an easy way for me to see how those things that an artist placed
Mhm.
get wired up to the model, or is it
Well, the model doesn't know about those. Really, the only time you add a new model or a model view is when you're making it a new type of something, which an artist or designer probably wouldn't do. So, for example, the block would be a new model, but afterwards you can place blocks wherever you want. So, like if you have a game where you're level editing, anytime you add a new type of piece is when you want a new model implementation. But if you already have your types of pieces defined, you can edit them in the view without changing the model or even
So-
the view model at all.
I guess what I'm wondering is, and maybe this is just a stupid question, but if I take my block and I move it over here in the editor, is there editor code that is populating the model's location values from
Gotcha.
the view?
So-
Because it seems like in the game, it's always the other way around.
Gotcha. No, there's not. If you want to do that and you were driving that from the model, then you'd have to like write down the values, close down, set them in the model, recompile, and reload it. Not the best workflow in that sense. But you don't keep that kind of stuff very often. We usually do that in the model there if it's like a function of something, like it's returning like tell me which column 0, 1, 2, 3, or 4 it's in, and that gives me a position. Like typically, if you need to go in and change the position, at least in Tumblestone, something more core is wrong in the code, so that needs done anyway.
I guess sort of playing off his last question, but in Tumblestone, you're building the board in code right at the time. You don't have a scene saved. So how would you handle building a level in the editor, like with 3D objects and things already in place? You don't have a view factory because the view already exists. It's in the scene. It's been saved.
Yeah,
So-
you wouldn't use the view factory in that sense. The view factory.
Do you have another way of like binding the model to the view that already exists, or
Oh, I see.
I know you guys don't do this for the game, but like how would you approach that?
I'm trying to think of in a case like that why a model would need to know where this corresponding view is.
So I think what they're trying to say is that they're trying to use the Unity editor to make a level in Super Mario Brothers.
Right.
And so you want to basically use Unity's tool itself.
Which is fine. I don't think that's. So you're saying the XY position in the model would need updated somehow.
Well, in this case, you're setting the XY position in the view, and that's already saved. So when you hit play, the views exist. The model's not been created yet. So how do you link those two? How do
As
you know?
an example of how we do this in Tumblestone, like the position of the simulations, for example, are chosen in the editor by the artist or whoever. And the answer is we don't have code running on those specific things. So in your prefab for the match, which describes basically everything, there'll be 4 placeholder positions where each board should be. And then when the game starts up, it reads where those positions are and feeds that information to the model if it's needed. So to use the Mario example, I would just have artwork that doesn't have any logic attached to it in the game. The game would process that on startup, throw away the artwork, or perhaps attach scripts to it if necessary.
In other words, the models the interfaces do have public setter functions, which you can use from your views up to the view models. So it's not like the models can't be edited by the views.
Right.
It's just that the models don't have a reference to the view models.
It's more about saving that view data at runtime. I mean, I know like it doesn't belong to the view; it belongs to the model. But when you're creating the scene in the editor, you're editing the view.
Right.
In that
So
propagate back. So
it can be set at runtime.
Yeah. I have one more question.
Yeah, go for it.
You talked briefly about the way you handle multi-platform support. How do you handle different assets on different platforms? Like we're doing a different version of our game for Vita, so we find ourselves needing a lot of like low-res assets and particle effects. So how do you
We have scripts for that. We have a menu in our Unity editor called Tumblestone, and we can go set platform and pick the platform. When that changes, we have scripts which place things. So we have a folder, maybe we don't currently have this folder, but we probably will, for like low-res assets and high-res assets. It'll just work. We basically write a script for like copy this folder here, and as you change platforms, it'll update all that.
Is that copying them in the asset database? So they're
Copying to the right place or outside of the asset database so they don't get referenced by Unity.
right.
But
That's during build time, right?
that's before go time. We kind of just do that manually in the Unity editor. We have like a little tab that we've made where we can do that, and that in turn does all this stuff, which is really quick. It's just copying stuff around, and then we build.
Could I give you a more concrete example? Maybe you could tell me how this works.
Okay.
So you have a block, and when the block is destroyed, it has an effect that it spits off. So in the view model script, the view script for that block, it has a game objects reference for a prefab.
Yeah.
And you drag something in, you drag in the high-res explosion.
You probably wouldn't. Oh, yeah. Okay. Then if you needed that reference there, I would actually opt for doing it at the texture level, the PNGs in a 2D game. I would have a low-res PNG that's named the same exact thing as the high-res PNG. You just copy it over, and then Unity doesn't really know something changed. It's like, okay, I guess they're using this texture now.
So that's the thing. We actually had this issue. We solved it by using asset bundles and then having, like, we rebuild the asset bundles with different assets depending on the platform. But Unity uses the GUID for all its assets. So even if you copy a different asset in, I guess that would work.
It just works.
Yeah.
It's just like if you have a 2D PNG and you open it up in Paint.net and scribble on it and save it, the scribble will show up in your Unity game. Same thing applies if you just take it, put it into a folder, take it something from something other folder, has the exact same name, and put it back in that place. This is a high res and this is a low res. That'll just work.
Does that lead to any issues with source control? Because if you have all these things under SVN or Mercure or whatever.
If you put it under SVN, don't move, copy. So rather than you'll have your assets folder and then you'll have a parallel, like I call it offloaded assets. So under offloaded assets you have Xbox One, PS4, blah. Everything's always there. Those aren't changing. In fact, anytime you want to make art edits, you'll do it in those folders and assume anything in assets is a temporary thing, which it kind of is. So what your script will do when you run it is it'll delete that thing in assets and then copy the appropriate thing over from offloaded assets. That way you have offloaded assets under your Git or source control or whatever you're using, and those aren't changed. What you probably would need to do is manually set all of these things that do constantly get changed to be ignored, but that's not a big deal. These are temporary things anyway.
You do it with like a pattern, just
Yeah.
strip it out.
Okay.
Okay.
Yeah.
That makes sense.
Just to follow up on that, I think if you use that approach and you're just using prefabs, you could take your original prefab, copy it into all of those places,
Mm-hmm.
then edit it, and then that saves you the need to do.
One of the things I don't like about doing it to the whole prefab, though, is if you want to make a change to the prefab, if you have that prefab existing in Xbox One, PS4, blah, for like 20 platforms, that's 20 places you need to change it. As opposed to a texture, if a prefab references the texture, you can just change the texture and make the prefab in one place and have that. Yeah, the complexity should be in one place.
So the game object that lives in the common DLL, is there any way that you componentize it in a similar way that you do this for moves, and is there a way you can customize that behavior if you're a designer?
I'm sorry, can you repeat the second part of your question?
It's like if a designer wants to make a change to how the behavior works, in some way, is there a way they can customize that behavior without, editing, putting float values that are driven to the DLL? Like where do you sort of
Nope. They would have to, yeah. Designers shouldn't be touching that code.
Right.
Or designers should learn how to program. That's the actual answer.
All right. Other questions? Okay. Thanks again. So real quick, we're going to open the floor up for announcements or job postings. If you have jobs you want to fill or you're looking for work, now's a great time to stand up and talk about it. I want to start with Tom Swanson over here. He's got a really interesting opportunity he wanted to talk to you guys about.
Hi, I'm Tom. I work at a not-for-profit organization called Foundry 10. We study learning and brain, typically not traditional learning. One of our programs that we offer to students, high school students, middle school students around Seattle for free is an internship program where they pitch us an idea. It could be anything. We've had hip hop choreography, an electric drag racing car. We've got an underwater submersible that does salvage. We've had high school kids building things and making things for a long time, but the biggest category that we get is game development. And while we've had Unreal Engine 4 kids coming through and saying, I want to build this game or that game, we finally have a group that really wants to do Unity. So I'm here to look for potential mentors for these groups. So what we provide the students is all the resources they need to complete their projects, as well as a mentor. And the mentor is a paid position. It's typically 3 to 4 hours per week at about $35 an hour. So we're looking for people who can come in and devote time either on Tuesday or Thursday for just a couple of hours and then be available on email for the students as questions arise. Most of the work is done by them. We just need the mentors to help them guide their project through development and then help them overcome the technical hurdles that they hit that they can't necessarily solve with YouTube videos and Google. So if you're interested, come talk to me. I'd be happy to talk to you and fill you in more on what it is that exactly that we're doing. We also, if you can't devote that much time, we do look for experts in specific areas like sound engineering. We had an AI guy come in and talk. We're looking for somebody who knows the Unreal Engine paint tool, so if you happen to know somebody who does that, it'd be great. But that is more of a volunteer thing, and it's just for like a couple of hours on Thursday. So if you're interested, again, just let me know, and I'd be happy to tell you more about it.
Where are you located?
We're down by Gasworks Park, pretty much between Gasworks and Ivers, in an old Brooks running shoe line, which is kind of cool.
We're down in Highline, like south by the airport.
So we have some stuff down there, some programs that we run.
Okay.
We're on the east side as well and up north in Shorewood, so we've got a lot of stuff going on. But yeah, right now our primary headquarters are at the Gasworks. We just cool.
Anybody else?
Yeah, so my name is Nathan, and basically I work at a staffing company. We do a lot of sourcing and helping fill positions for a lot of the gaming companies. There's at least several of them in the area. So if you're looking for a job, I'm always here. Love to have a conversation. It's